Hello, I'm Alan Leonard, and I'm going through my answers for the Comp 4320 Introduction to Networks Lab 3. So for the first part was looking at the capture trace files we did using the ping grapher. I forget what the program was called, but we recorded it as we were doing it. So for the first part, I found IP address was 10.2.1.156. I had the screenshot of that. Then for the within the IP packet header, what was the value in the upper layer protocol field? I found that to be 256 with the being 0x01. Highlight that part too. How many bytes are in the IP header and how many bytes are in the payload of the IP datagram? And I explain how I found that. For the first part, found the header length, highlighted that was 20, total length was 56, which means the payload was 36 because it was 56, which is the total thing minus the header. Number 4 was the IP datagram a fragment. No, I found the fragment offset to be 0. And then I found for number 5, which fields in the IP datagram always change from one datagram to the next within this, and what fields stay constant, which fields must stay constant, which fields must change. So I found the checksum and identifier always chained on them. On the opposite side, most of the field didn't change, like the version, the length, the flags, the header field, etc. Though almost all of those things stay the same. I highlighted all of them on both one, and I highlighted the second one, and showing the differences and the things that stay the same. The reason for the identifiers changes is showing them like go down one by one. The checksum changes with like modifications, but they are overall the same or the rest of the way through. Number 5, which fields in the I just did that, sorry. Number 6, describe the pattern you see. The pattern identifier was that it was going up one by one per message, and that's also shown in the screenshots above. Number 7 was the value in the identification field and TTL field. And the first one, the identifier was 3301, with the TTL field being 255 before it reset. Then it went up to 3302, with the TTL being at 1 as it restarted, and as they kept going, they both went up one by one. And number 8, do these values remain unchanged for all of the ICMP exceeded replies sent to a computer? I found that the replies seemed to have both numbers different and not in any pattern because they were being replied back in varying ways and connections. So these had were basically always unique. And I mean, the identifiers would be still going up, but they wouldn't be incrementally going up. And the checksums were always, or the TTLs were always different. For fragmentation, which is when we start going through the second parts of the point plot, because the first part we were doing 56 bytes, second we were doing 2,000, the third part we were doing 3,000. Seeing how far we go up, and there were some hard for me to scroll through and find most of them, but I did. So number 1, the first message, has message been fragmented? And I did find it was fragmented. I showed the fragment offset highlighted. Number 2, the fragment flags after finding like the printout. What information the IP header indicates the data has been fragmented? It was the flags right underneath it, and below the identification it shows flag 0x1, more fragments telling us this. And also the first one had fragment offset 0, or sorry, the second one had fragment offset 0, showing the first one had the offset, the second one did not. It was like how much was offset, the next one needs to be offsetted by, and the next wasn't at all. This is the whole datagram was about 1,500 bytes, or this total length in the second part. So it was fragmented across 2 different ones. Print out the second fragment at the fragment IP. Second message had an offset of 1480, showing not the beginning. While there are longer fragments because the flag is empty, it does not tell us more about the fragments. It just tells us that it is. But since it also, the second part had flags 0, that tells us that was the last fragment. And number 4, what fields changed in the IP between the first and second? Going off the screenshots I took, changes in the header and total flag length, flags given to us, all that changed with it, as it did. How many fragments were created from the original datagram? 5. Going using about 3,000 byte packets for that one with 3 fragments created. 6. What changes in the IP among the fragments was length, checksum fragment, offset, and flags given. And the final offset being about 2,960, but I also include screenshots for most of those parts above. Part 2, network address. See IP of the client. We found that it was 192.168.1.100. The destination being 10.119.240.64. For the second part, it wasn't really a question. It was just asking about the screenshot showing that I was able to correctly format across it. Number 3, were the source and destination IP addresses across the TCP port. And I posted those. I'll have to say them out because they're all complicated. Posted the time for number 4 with the source ports along with it and everything again. And then for the 5, getting the get command from the HTTP with the SYN and the ACK handshake. Wrote the time, the IPs for all of that, showing with the screenshots as well. And for the last part, we're showing the NAT connection, changing all of this. From number 1, posted the screenshots of all of this with the information. The difference being the time and the source address as it has been changed for the router. This is different from the client side compared to the service one. For the second one, there was not a difference in the message given or anything. None of the fields above have been changed, including the screenshot I took. Number 3, on the change file, same thing happened with the 200 get and the OK HTTP. Was just the only difference being the time, of course, being having to go through the router, translation and everything, and also the source IP address being changed across it.